Hello everyone, TopHATwaffle here once again to continue working on our Counter-Strike Global Offensive competitive level. Today we will be importing custom textures and materials into Counter-Strike Go so that our level can stand out and be more unique. We're not going to start by loading Hammer. Every time we import a new material we have to reload Hammer, so it's just easier to not even start with it open. I've gathered some textures and materials that I want to import into CSGO. These are just from textures.com. I have a concrete texture, 2 marble textures, a decal texture, and a transparent grate texture, along with 2 normal maps. We'll start by doing the easiest, which is just a single texture with no other fancy parameters on it. The easiest way to import materials into the game is by using VTF-Edit. This is a tool by Nem, and I keep a mirror of it on my website. If we head over to tophatwaffle.com/downloads, then scroll down to the texture tool section and download VTF-Edit, and then install it. This is just a full next installer, and we can associate it with VTF files. Before we import any materials, one thing to know is that Source Engine requires that all materials be a power of 2. They don't need to be square, but they do need to be a power of 2. These are values such as 2, 4, 8, 16, 32, all the way up to 4096. We're allowed to have materials that are, say, 1024 high by 2048 wide, or 16 high by 512 wide. If we load VTF-Edit, and then go to File, Import, we can select the texture to be imported. After we click Open, we'll get the VTF importer options. The default options will work for most textures that you're importing. VTF-Edit will automatically resize an image if it's not already a power of 2 for you. But since this image is already a power of 2, it won't need to be resized. Click OK to import the image. And here we go. This is a concrete tile texture. And if we go under View, we can preview what the texture will look like tiled. This is a helpful feature to use to make sure there are no seams in your texture while it's repeating. If we click File and then Save As, we'll be able to save the image as the VTF file format, which is what all Source Engine games use. I'll save this as Brick01. We now need to take the VTF version of the image and put it into our game directory. If we go to Steam Apps, Common, CSGO, and then into our Materials folder, let's create a new folder here. It's a good idea to keep all of the textures and assets for your map in their own folders just to stay organized. I'll create this new folder called DE Metro. I'll drag the VTF file in, and then we can double click to open it once again. Now let's go to Tools and create VMT file. The VMT file is essentially a companion file that the Source Engine uses to define additional parameters about your texture, such as, is it grass? Is it concrete? Should it be reflective? Do I have height information? VTF-Edit is a great way to automatically create these very quickly. By default, it will automatically include the base texture, which is the VTF file that it's looking for. If I go under Options, we'll see that we have the shader of light mapped generic. This is telling the engine that this texture should use the light map to receive lighting. If a material that you've created isn't working, you may want to check to make sure that the shader is properly set. Underneath we have Surface 1. This is what defines what it should sound like when you shoot it and walk on it. I'll select Concrete, and then we can just click Create. It will ask us where to save it. I'll also save this to my game folder, and I'll save it as brick01.vmt. Inside of the Materials DE Metro folder now, I have brick01.vmt. VMT files are just text files, and we can open them with a text editor like Notepad or Notepad++. To do some more advanced material things, we either have to do it by hand or use other third-party tools that you can find online. Now that we have a VMT and a VTF file, we're able to use this texture inside of Hammer on our level. Let's load up Hammer. Once Hammer's loaded, let's open up the Face Edit sheet and then browse for a texture. Let's do a search for DE Metro, since that's the folder that this texture is in. I can see that I have the small preview, and if I double click it, I can right click to apply it to some faces here. That doesn't look too shabby. Let's go take a look at that in game. Here we are in game now. We can see that we have our custom texture applied to the ground. If we want to see what texture we're looking at in game, we can open the console and type mat_crosshair. This will return the material under our crosshair. in this case, DE Metro / Brick01. This texture doesn't look too bad, but it's very flat. It's missing any height information that these bricks would normally have in the real world, such as the divots in between the bricks themselves. To get this depth information, we need to use a normal map. A normal map looks something like this. This is the normal map that was provided from textures.com for this specific texture. There's various texture tools that you can use to generate your own normal maps, such as VTF-Edit has a built-in one. There's the NVIDIA normal map tools for Photoshop, Bitmap to Material, Crazy Bump, and a ton of others. This falls under more of texture and asset art creation, so I'm not going to go too in-depth on it here. Since I already have this normal map and it was provided for me, let's apply it to a different material so we can take a look at them side by side in game. Going back to VTF-Edit, let's click File and then Import. And we want to open up the concrete tile normal. We'll use all default settings again. Going to File and then Save As. I'll save it into my game directory as Brick01 _ normal. Now I have one VMT and two VTFs in this directory. Let's copy our Brick01 VMT and also rename it to bumped. Inside of Brick01 _ bumped, let's add a new line that is $bump map, and then the path to the normal map that we just created. This is telling the game that when we use the Brick01 bumped to use this set of parameters. In this case, we'll have a base texture, concrete, and it'll have a bump map pointing to the normal texture that we just created. And now we need to reload Hammer so Hammer can pick up the new material. If we do another browse for DE Metro, we can see that we have two textures. The preview will be no different between the two, but we can see that this one says bumped. I've only applied bump mapping to this face, so we can use this one as a direct comparison of bump versus no bump. Let's recompile it so we can see what it looks like. Here we are back in game. On the left side, we have the bumped version, and on the right, we have the just flat version. The details are subtle, but they look very good. For instance, on this brick here, we can see that the light is hitting this edge of the crack, or as opposed over here, nothing's happening. We can also view the additional lighting information that's being cast here by using the matte Fullbright 2 command that we used in the lighting tutorial. This will allow us to visualize how the light is being cast onto this normal mapped surface. Using a normal map isn't required for all of your custom textures. You should use it where you think you'll get a benefit out of it. I like to make sure I use normal mapping on brick materials, cobblestone, other things that are very bumpy that you'll see the lighting information from. It also helps make your level look much less flat. What about transparent textures? Most of the time, a transparent texture that you get will be a PNG value, since those do have transparency in them. Unfortunately, they lack the proper alpha channel that we need to get proper transparency out of them when bitmaps come into play. If I import the PNG that I have, we can see that the tiling checker behind it means that it is transparent. If I turn the mask off, we see that everything is filled with white. This poses a similar problem as in the texture tutorial, where when we start to zoom out and the bitmap switch, we'll see a white glow around these holes in the texture. This is due to bitmap filtering, and it's pretty easy to fix. We just have to do a little work in our photo editing software. Let's open that texture up in Photoshop, GIMP, or whatever, and we want to select the parts of the texture that will be transparent. We come over to Channels and click New, and then just hit Delete. By doing that, we've created an alpha channel that will contain all of the transparent areas. Let's turn all those back on, and we need to create one more layer underneath. Let's grab our color picker and then just choose a brown color and fill in the background. It doesn't look quite right, but that's because we don't have the mask combined with the rest of the texture. If we turn the mask on, we can see that we have the transparent bits where they should be. Let's go to File and then Save As. And we want to save this as a TGA file. You can save it as 32 bits a pixel and click OK. And now let's import this into VTF-Edit. We see that we have the brown behind the grates, and when we turn the mask on by pressing Ctrl M, we see that it looks exactly how it should. This texture will not have any distance issues with Cubemaps. Let's click File and save this as a VTF. And let's make sure we put the VTF inside of our DE Metro folder. After we copy it, let's open it up again and go to Tools, Create VMT File. Under Options, we want to select Translucent. I'll also set its surface property to metal and click Create. I'll save the VMT into my CSGO materials folder. We see that we have the base texture, like before, surface property of metal, and translucent 1. This parameter tells the engine that this texture should be translucent and to use the alpha channel to figure out where it should be see-through. Let's reload Hammer once again. Inside of Hammer, inside of my vent, I've created a small little holder that I want to place this grade on top of. I'll select my no-draw texture and create a brush on top of it. I'll make it a func detail, and then I'll open my face edit sheet and do another browse for Metro. I see that I have my metal grate material here. I'll double click to select it and right click to apply it. It's a little big. This is one of these situations where I'll use the fit justify option. Let's go ahead and take a look at that in game. Here we are back in game. If I walk over to the vent and look up, there's the grate that we just created. And if we fly away from it, we won't have any bitmap issues due to the brown layer behind the texture that we placed in Photoshop. The final thing that we'll go over are cubed map reflections in our level. These are done by creating MV cube maps throughout the level and then building cube maps, which are then later assigned to faces that request them using a VMT parameter. Down in the Metro, I have this custom tile texture. Inside of the VMT is just a very basic base texture, surface prop, and bump map like we just previously created. If we want to tell the game that this texture should be reflected, we can do this by adding one line. By adding $NVMap, NV_CubeMap, this tells the engine that we want an NVMap applied to this texture, and we want to use an NVCubeMap entity to do so. Since this texture already exists in Hammer, we don't have to reload Hammer for it to update. Once we go back to Hammer, we can see that this texture now has a weird shine to it. This is reflecting the current default cube maps, which is of the DE Vertigo skybox. This is normal operation and nothing is wrong. This is just how Hammer handles reflective materials. Let's compile that and see what it looks like in game. When we come down to our Metro, there are no reflections on this material. This is because we have no NV cube maps like I previously mentioned. We have to have an NV cube map present in our level for there to even be reflections in the map. Switching back to Hammer, let's create a few NV cube maps using the entity tool. We'll place a new entity and we just want to change this class to NV_CubeMap. We're left with this little chrome looking sphere. We want to raise the NV cube map up to be at player height so the reflections make the most sense. The easiest way to do that is to put the NV cube map onto your clipboard. NV cube maps should typically be placed throughout the level where players can navigate. In this area here, I'll place one right here, over in the bomb site, here, and right there. We'll also want to place them in areas of high contrast, so that way if we're in a hallway, we're not reflecting anything that could be on the outside. The weapon scopes in the game will reflect the closest cube map that the player is to. So if we're inside this room here, we don't want to be reflecting this cube map outside. In this instance, I'll put another cube map in here, and that should take care of that. We'll also want to put another cube map about right here to handle this transition. Now we need to raise the cube maps up. The origin point, which is in the exact center, needs to be 64 units up from the ground. Let's go to Map and then Entity Report, and just select all of our NV cube maps. Press Ctrl M to open the Transform dialog, select Move, and we want to go 56 units on the Z axis. Click OK, and all of the cube maps will shoot up, and they're now at player eye height. Now let's compile and see what difference that has made in game. There's still no reflections happening on our tiles. Let's open the console and type build cube maps. What we just saw was the game taking snapshots around each NV cube map entity, and then save that information into the BSP file and has applied it to our textures. We can see here that this rainbow checkered board pattern that I applied to these Metro cars has been successfully applied and reflected in the ground. One thing you may notice is a harsh change in reflections between where brushes are. This is due to the cube map over here reflecting this orange wall, but this one is reflecting this wall here. There's no perfect world situation fix for this, but we can assign faces to use a specific cube map. Let's go back to Hammer. We can select this NV cube map here, and then under brush faces, let's choose pick, click on this face here, and while holding control, click on this other face, along with this one and this one. I'll then move this cube map over here and choose pick again, and we'll have these faces share this cube map. This cube map will power these three faces. I don't need that one. And this cube map will handle these. And this one will handle these over here. You don't have to manually assign these, as it does do it automatically for you. But manually assigning them can fix that harsh change in reflection when we switch from one cube map to another on a texture. One other thing I'd like to look at is the cube map size. The default is 32 by 32. This means that the image that the game is taking a picture of is shrunken down to a 32 by 32 image. This results in essentially a reflection being a cube mapped 32 by 32 image. We can increase the size of the cube map for higher detailed reflections. I'll set this one to 256 by 256. You should also take care to not just set every cube map in your level to use the 256 by 256 or a higher cube map size. This is another thing that you should set in areas where it will make the most impact. Increasing this limit does increase the map file size along with the rendering power and memory needed to store the reflections. Let's click apply and we'll recompile so these changes can be made. We're back in game after the compile, and look at that, all of our reflections are gone. We have to rebuild the cube maps after every compile if we want to see them. So once again, I'll do build cube maps in console. And then our reflections are back. We can see that the seam between these two is now gone. The rainbow checkered pattern is also extremely high detailed now in our reflections. This is due to the 256 by 256 cube mapped image. If we come over here, we can see the switch between the two of the default cube map and the other cube map. The default size cube map has the general colors of the area that the reflections were taken of, while the 256 by 256, we can make out the object that is in the reflection. If we think our reflections are too strong, we can turn them down and fine-tune them with a few other VMT parameters. If we open our VMT for this material and just keep it here, let's add a new line of $NVMap tint. And in here, we're going to store a matrix of RGB. By default, the matrix is 111, which means we have full red, green, and blue. If I set this to 0 and 0, that means that the reflections will be full red, no green or blue. I can then in my console type mat reload all materials. This will tell the engine to reload all the materials and we'll be able to see this change live. Now the reflected images are only red. In most situations, you'll use this as a scale for your reflections. If I set this back to full reflectivity, and then let's set it to 0.3. With 0.3 for each of these, there will only be 30% of the current reflections. Let's save that and mat reload all materials. And now the reflection amount has gone down significantly. We can use this value to fine-tune and reduce the reflections in areas where we think they're too strong. I'll set this to 0.8 on each. And let's take a look at another command that we can use to help tune our reflections. $NVMap saturation. And this can be any value we want, where 1 is normal saturation. We can oversaturate our colors, or completely remove the saturation to make them black and white. If I set this to 0.7, this will only be 70% of full saturation. Now let's take a look at NVMap contrast. This will allow us to take out some of the contrast from the image, which can remove some of the over brightness that we have over here. So doing $NVMap contrast, the default value is 0. If I set this value to 1, we can see that we still have the colors over here, but the reflections over here are much better. They're reflecting much less of the sky. We can also set this to 0.5 to only get half of that adjustment. Setting this value is a great way to combat the sky or just overly bright hotspot reflections. I think this looks pretty good at 0.6. A console command that's useful for troubleshooting cube maps is r_show_cubemap1. This will apply a full reflective material to your current weapon. Giving ourselves a bigger weapon like an AWP, we can see how the reflections will change as we walk around. The current cube map that I'm in is the 256 by 256. We can make out the tiles and the image on the train car behind us. But if I step to the right, we'll switch to the default size cube map. This will let us see the true difference between the two. We can see that when I walk in here, my cube map changes approximately where the door is. This will combat if I'm inside, we shouldn't see the outside cube map. That's gonna wrap up our first look at custom content in our own level. Join us next time when we do info overlays and decals along with packing our level for shipment to other people. Thanks for watching, we really appreciate it. Remember, there are no mistakes, just happy little accidents.